Okay, in this notebook, we're going to start playing around with Pandas. Pandas is a relative newcomer to Python that arose in the financial world but has quickly taken hold, become a core library for data analysis generally within Python. And so when you get into machine learning, uh, that will typically all the tools we'll use, like in scikit-learn, will all not necessarily assume, but will certainly work with Pandas data frames and Pandas series. So Pandas organizes data into either what they call a series, which would be a one-dimensional sequence of data like we have used with ECG data, or a data frame, so a 2D data, which would be the kind of tabular data you're used to working with in like Excel. They also have higher dimensional data structures like a panel or a 4D panel or an ND panel, but we're not going to touch on these. And at the time that I created this notebook, these were all considered experimental, and I honestly don't know what their current status is within Pandas. In this notebook, we're really going to kind of focus on Pandas's ability to facilitate input-output. Well, in this notebook, input. And that's everything that we're going to do in this notebook you could do without Pandas, but Pandas just makes it that much easier, much easier for us to work with. So there's one of the beauties of Pandas is it knows how to read in so many different file formats. And not only just read it in, but recognize what kind of data are in each of our columns and do that conversion for us. If we were starting from scratch and opening a file, and I guess we kind of did this in class where we were using this CSV reader to read in CSV file. Everything was coming in as a string, and then if we had floats or ints, etc., we would have had to converted each of those strings into the appropriate numeric type. And Pandas will attempt to do that for us. So there's tabular data, and it has functions for reading in comma-separated files, read CSV, tab-separated files, read table. These are really the same underlying file with different default values for the delimiter that's separating each data element in the rows. And we can specify our own delimiter and use either of these functions to read whatever kind of tabular data that is separated with whatever arbitrary delimiter we have. It can also read directly from relational databases with the read SQL function, has support for high performance file formats such as HDF5, which is designed for very large data, and we'll look at this in a separate notebook, and to read proprietary data in a proprietary format, such as an Excel file with the read Excel. For any of these data types, Pandas can either read from a local disk or a remote resource using, for example, HTTP or FTP protocols, and we'll go over each of these. It can also recognize compressed data, do the decompression for us and read it in, and has the ability to read in a large amount of data. We'll have a notebook where we'll read in some 6 million rows of data, and I believe Excel has a limit of approximately 1 million rows in the file size it can read in. Okay, so the first thing we'll demonstrate is reading a remote file using the FTP protocol. Now, FTP is a very old standard. It stands for File Transfer Protocol, and in this case, we are going to look at data that's stored at NCBI at the NIH, and this is data that Karen Eelbeck works with for ClinVar. What's the attempts to help researchers understand what's the clinical significance of variations in variants in gene expression. And so it's going to be a tab delimited file, so we're going to use the read table, and we're just going to give it the URL address. And so it's hosted on an FTP server, And so we need to say what the protocol we're going to be using, and that's what this FTP is here, colon, and then the address of where it's located. And then we're going to use this head function of clinvar to just show us the first few rows in the data that we read in. Now, because this is being read over the internet, we're going to have some delays in the time that's coming. So, in addition to FTP, we can use we can also read data using an HTTP protocol. And in this case, I'm listing HTTPS, but the actual data that we're going to be looking is not on an HTTPS server. That's just an encrypted server. Okay, so here we are back here with our tabular data. And in my mind, there's some advantages as we're working to not have to separately download the file and then read it in. For reproducibility, we might want to do that because these files change over time and etc. But just kind of demonstrating the convenience of giving it an FTP location and then getting the data directly into our program. Okay, in this case, in this next example, we're going to use an HTTP protocol. So what does HTTP stand for? Hypertext Transfer Protocol. I'm sure that's not exactly right. This is some data we have stored on our local system here. So we have a web server called MyNginX, and we have various pieces of data stored over there. The reason I'm using this instead of like a remote resource is because the original data that I had used is now no longer available from the census, which is one of the challenges of the continuous dynamic web. So we have a tab-separated file. I'm sitting over on MyNginX that's hosted on this web address, http://mynginx/data top 100 ICD-9 text. So these are the top 100 pediatric ICD-9 diagnoses. And again, we're going to use read table. In this case, if we look up here, we just gave the address. And Pandas was able to recognize that the first row, well, maybe not recognize, it just assumes that your first row is a header row, and then the data follows. For this file, there is no header, and so I need to tell it header equals none. And when I do this, this is what my data look like. If I were to eliminate that header equals none, it's going to assume that first row is a header, and so I'm kind of mangling my data a little bit. So I want to change that back. So in some sense, it helps to know what our data are going to look like. The data frame has a shape. In this case, we have 100 rows of data that we've read in and 5 columns. Okay, we can read from a relational database, SQLite, which is what I'm going to demonstrate here, or most any type of relational database through SQL Alchemy would be supported for reading with Pandas. So in this case, we have a SQLite database that is all the foods that are mentioned throughout all the episodes of the Seinfeld TV show. So in order to read from the relational database, we first make a connection to that database, and then the read SQL takes a SQL command. In this case, we're going to do a query. We're going to select all the columns from the table episodes, and then we pass the connection that we created. And here's what we read in. We have the name of the episode, what season it is in. The pilot wasn't part of a season, so it's a missing value, which Pandas by default assigns a not a number to. Okay, we can also read from a Python-specific file format like pickle. And here we have a pickle file that's located in our data directory. And so we're going to use the pandas read pickle. And this is a tabular file where we have a number of radiology reports and corresponding ICD-9 codes for that patient and the subject ID. And finally, we can read in, and there are more formats that can read in just in this demonstration, that we can read in a JSON file. And so I've taken this, the top 100 ICD-9 codes that we read in previously, converted that to a JSON file, which I've added to the repository, and we can read that directly in from the JSON, and it will parse it into this data frame for us to work with.